So welcome back to another exercise lecture for system Verilog constraint. In this video, we will try to find a trick to generate a constraint for certain patterns in which a certain digit is being repeated for multiple times. So for example, if we want to generate a pattern which looks something like this, and so on. So our aim is to generate this particular pattern using the power of system Verilog constraint. So here, first thing you have to do is to detect a unique pattern, and that unique pattern is being repeated multiple times. So if you will look at it closely, the very first digit is 1, then the second digit is 0, then the third digit is 0, and the fourth digit is 1. And then the fifth digit is 1, then 0, 0, 1, and then 1, 0, 0, 1. So here you could clearly see that there is a unique uh, number, a certain digit pattern, and that pattern is getting repeated multiple times in a row. So first you have to detect whether there is a unique pattern, and that same pattern is being repeated throughout the entire vector. After that, we will begin writing our system Verilog constraint, and you just have to assume a place for each of the number. So let's say the first number is at 0th place, then the second digit is at first place, then the third one is at second place, and the fourth one is at third place. And there are total number of 4 digits. So you have to keep that in your mind. And after this, let's begin with our constraint. First, we will write a class. Let's call it const pattern, or you could name it whatever you want. After this, we will begin with our constraint. So first, let's declare a random variable. Let us assume that it is of type int, and let's name it a. Let's begin with our constraint. So for this particular constraint, you first have to iterate through every bit, and for that we will use for each. And after that, inside for each, we have to use if conditions, and we will use the modulus operator to implement this particular pattern. And we have to use that modulus operator for our iteration variable I. So I have already uh, mentioned here that there are 4 digits in total for this particular unique pattern, and we are assuming that each digit have a place ranging from 0 to 3. So, so we will do the modulus of I with the total number of digits, and those total number of digits are 4. So 4, and then we will equate it to the desired position. So let's say we are targeting the all the places which have 1. So the first place, or sorry, the 0th place has 1. So if I modulus 4, 4 is the total number of digit, is 0, then we will say AI equals to 1. So if I modulus 4 equals to 0, where 0 is the position and 4 is the total number of digits for that particular unique pattern, and I is the iteration variable. If that is the case, then that particular digit inside the random int a will be 1. And same is the case for the third position. So we will or, remember not to add it, just or it. We will or, and then we will write the same thing, I modulus total number of digits, which are 4, and then the position. And in this case, the position is the third position, since we are counting from the 0th position. So if it is the third position, then also the AI should be 1. Now we could write else if I modulus 4 equals to 1 or I modulus 4 equals to 2, then AI is equals to 0. But since we have already covered uh, all the uh, all the place which have 1, we will simply write that else AI will be equals to 0. So using the modulus operator and assessing the total number of digits and equating them with the position, we could write constraint using the if else. Now let's see whether this works or not. So first I will write a post randomize function to print everything. And inside this, I will display the value of A in binary. So let's begin with our main module. First, we will declare the handle for the class. Let's name the handle as CP. Then we will begin with our initial block. And inside our initial block, first we will assign an object to the handle. And then we will randomize it. So let's go ahead and compile the code and check whether we have encountered any compilation errors or we have made any typos. Okay, we have no errors. Yeah, so this is a simple warning that uh, because the randomize method returns true or false, so uh, it is just saying that in this case it is not returning anything. So just to avoid that error, you could just write do a cast using void. So you could just do a static cast. So in this way, we could just avoid the warning, which will not affect the code in any way, but still, let's compile it again. So now we don't have any warnings. So let's begin with the simulation. And the name of the module is test. So I will be starting the simulation with test. Okay, let's run the simulation. So here you can see that we are getting the desired pattern. And since A is an int, it has 32 bits and we are printing the value in binary. So you could see that it is the desired pattern 1001, 1001, 1001, and so on. So this is a simple trick that using the modulus operator and just counting the total number of digits and equating them in the condition uh, to the position for which you want to override a certain value, you could just write a constraint to generate such kind of unique patterns which are getting repeated throughout the bit vector, or even in the case of elements of let's say a dynamic array. So let's just write another example. So in this time, let us assume that there are going to be like there is going to be a pattern like this: 1 0 1 0 0, then 1 0 1 0 0, and so on. So first, as like with our previous class, we will first try to detect the unique pattern, and that unique pattern is, as you can see, 1 0 1 0 0, then again 1 0 1 0 0. So that unique pattern is this, and total number of digits this time are equal to 5. So there are a total number of 5 digits in this unique pattern, and uh, we will be uh, we will be assuming the position ranging from 0 to 5. This one is 0th position, then this is first position, this second position, this is third and fourth. Sorry, 0 to 4th. So we will be assuming the positions ranging from 0 to 4, just like you will do with any arrays or etc. So let us just write a class for this. Let's call this class pattern underscore 2, and this time let's just say we want to write this pattern for a random int b. So we will begin with our constraint. I will call it pattern underscore b underscore c. So we will do the same thing. We will iterate through each of the bits. Oh, sorry, this time it is b. Then we will write the condition using the modulus operator, and we will write that modulus operator with the iteration variable I. So, here, as you can remember in our previous class, after modulus, you should be writing the total number of digits. So there are a total number of 5 digits. So I will write 5 equals to. So let's say our if condition is targeting all the bits with 1 as a value. So the 0th bit has a value of 1. So we will write the position 0, and then we will OR it, and we will write it again, and this time we will write it for the another one which is at the second position. So I modulus the total number of digits is equals to 2. So if this is the case, then that particular bit should be 1, else the remainder of the bits are 0. So else the bits will be 0. So this concludes our constraint for the pattern of 1 0 1 0 0 being repeated multiple times. So let's write a post randomized function. So inside this post randomized function, we will just display the value using the display system task for b in binary. So let us go ahead and uh, write another handle, and this time for the class pattern 2. Let's name the handle as p2. Let's assign the object to p2, and let's randomize it. And let's just do the static cast using void, and just to avoid any warnings. So let's go ahead and compile the code and check whether we have made any typos. Okay, we did have an error, line number 29. Okay, so in the condition, I just put A, uh, whereas our targeted random variable is B. So yeah, this is the typo which was made in hurry. Let's see whether it runs perfectly this time. Okay, it's fine now. So let's start the simulation. Let's run it. Okay, so this is for the previous pattern of 101, and this one is our new pattern, and you can see it that it is starting from 0, then 1, 0, 0, 1, 0. Then again you can see it that, just a second. Oh, all right, yeah. So since we have declared it as a int, we are supposed to start counting it from the LSB. So for this pattern, because it was uniform, so um, we didn't have any like changes, but we should start like considering it from this side. So it is 1 0 1 0 0 1 0 1 0 0 1 0 1 0 0. So we got the desired pattern. So yeah, so that's all for such kind of questions in which patterns are being repeated multiple times. So you could use the modulus operator. So inside the constant, you will just iterate through each of the bits, and you will put conditions, and you also have to determine the total number of digits for that unique pattern. And then using this condition, you could just modify those particular positions as per the pattern needs. So that's all for this video. I hope you find this particular video useful. Thank you so much, and stay tuned for more. Thank you.